Good afternoon. I'm Teresa Potter, Community Engagement Manager for FLATE. Welcome to our 2023-24 webinar series. Today's topic is AI in manufacturing. We're going to spend just a moment introducing FLATE, and then we'll get right to our speaker. FLATE is part of Florida Makes, whose mission is to support and strengthen Florida's high-wage manufacturing sector. FLATE, which stands for the Florida Advanced Technological Education Center, is the education arm. And our mission is to drive Florida's manufacturing workforce education and training. We do this in a variety of ways, which Daniele Orozco-Cole, our Career and Technical Education Manager, will touch on briefly in just a moment. Our FLATE team also consists of Ernie Friend, our Executive Director, and Marilyn Barger, our Senior Education Advisor. Daniele?
Thank you, Teresa. So like Teresa was mentioning, FLATE's mission is to improve and advance technician education. We focus into year AS degree through curriculum reform, developing the STEM pipelines that fit into them, and professional development. I want to focus especially in the student pipeline, how we do that. Many opportunities we have as an outreach. Some of them are like manufacturing month events, which is usually October of every year, but this is not only in October. We should work every single day of the year, recruiting and planting the seed on those events. And that's David. Could you mute the phone? Or Teresa, could you mute this phone? And in addition to that, how we can help with the pipelines and recruiting those technicians. Helping in any way, opening the doors for those of you who are manufacturing, for those of you that work in college, just opening also your colleges and do career expos, inviting more manufacturers to your board meetings, do career expos for manufacturers or educators. Go to the schools and be part of education day or manufacturing day, whatever you want to call it. Talk about what we do in manufacturing, how fun it is, and provide examples of the equipment or parts that you produce and you make, things like that. Everything that is required is valid to promote and recruit students. Again, planting the seed is the key. Professional development is, as an example, what we have this afternoon using our FLATE webinars. We do a lot of workshops for educators and a lot of presentations to keep faculty and educators on top, always having the latest of the latest in education. Next, Teresa. Here are some of the resources that we have. 3 of the main websites are FLATE.org website, where we have everything what we do with the latest resources, but you want to go more in depth. If you are an educator, you can visit madeinflorida.org. And it's also for industry. We have for everyone a little bit, and even students, if you just visit. And I know I'm taking too much of time, and this is precious time that you are going to learn with Ron. Ron, please.
All right. Everybody, hopefully, hey, Danielle has my microphone. Is it good?
Yes.
Yeah, you can hear me fine? Okay, yes. Well, what we're going to talk about is I'm Dr. Ron England. I'm a professor here at Daytona State College. We're going to kind of get, this is an overview, so we can go to the next slide. So what we're going to be looking at is today. What does it look like today in the world of AI and how it's being used in manufacturing essentially right now, which is amazing because it's very challenging to find out who's doing what, because many of the companies that are using AI are also very tight-lipped about what they're doing. There is an advantage associated with this. So let's go forward. So first thing we want to do is get an idea of what is out there, the different kind of functions that AI has. And when you talk about artificial intelligence, you can talk about it in a number of different types of areas. One is you can look at AI by what AI is. And right now, there's a lot of people working on a lot of different types of AIs. But what I'm going to do is look at AI by what it does. So one of the things right now that is being used throughout all of the AIs, and it's being done through machine learning techniques, is natural language processing. This is a layer that's going to sit on top of a lot of the types of AIs that we're going to talk about today. In other words, when I say an AI, you may actually be talking about a bunch of AIs. You may have a natural language processing interface that converts to text, that sets that to a bunch of commands. The commands are then fed into another AI that does something else with it. So there's layers to AI, but just the things that we've become used to, the ability to say, Alexa, do something, that is an AI. There's the natural language processing associated with that is an artificial intelligence. It's a network that is able to do that. All right, we'll go forward. Another one of the different ones, which is also used heavily in manufacturing and heavily everywhere now, is the concept of computer vision. And back at UCF, when I was there was the computer vision lab where a lot of this stuff was actually being developed. And the picture you see here is a type of computer vision system where the computer is been trained to recognize things. And what is really demonstrated is the limitations. So when you train a computer vision AI system, you train it specifically to recognize things that you've trained it to recognize. So if you've trained it to recognize cars and traffic lights, that's what it can recognize. It doesn't know anything about anything else in those images or video, because it can do both. All right, the next one that we have here is the one that we're going to talk about the most, which is the machine learning type of function. And in this case, there are different ways to look at machine learning. And the reason we're going to kind of delve into this a little bit closer, and I'm going to move this out of the way here. So the reason we're going to delve into this the most is because it's the one that you're going to see most commonly in the manufacturing settings. Most of the examples that you're going to find in manufacturing right now are what's called supervised machine learning. We have data that has some sort of outcome that goes with that data. We can look at the data and we can say, hey, this is going to happen. But we can also train a machine to do exactly the same thing. You've also seen now some systems that have unsupervised, and which is basically throw the data at it, but let it draw its own conclusions. And there's specific kind of AIs to do that. We're also using in the manufacturing sector the concept of reinforcement, that once you've got an AI model, you can see, and the models aren't perfect. The beauty of the models is they get better and better. But you can have reinforcement by looking at supervised models and then seeing the mistakes and then having it learn from those mistakes not to make those mistakes again. All right, we'll go forward one more. Now, okay, there we go. So this is what we're going to be doing. This is the one that if you're going to understand one model and understand it well, and there's a whole bunch of them, this is the one: supervised machine learning. So what do you need to do this? It's kind of the big thing is how do I start with this whole thing? And the start may just be understanding how it works. So the first thing that you have to have for a supervised model, so to create the AI, is some data to train it with. Just like humans, the AI learns from given input that leads to an output. That's data. You need the inputs, you need the outputs. Once you have that, you can look at that data and say, there's a lot of different kinds of AI models. There's AI models that can be fed text, which give you text. They're fed numbers, which give you numbers. Numbers that give you text. pictures that give you text, pictures that give you numbers. All these models, this is the area where you have the AI specialists, the ones that come in and say, looking at the type of data that we're starting with and the type of data that we want to get as a conclusion, this is the type of model that we'll do. In the end, you really don't care. You've got input, you've got output, and you want it you want to be able to feed input to it and get expected outcome outputs that make sense. Once you've got a model built, you can start implementing the model. And you're going to see real examples, which means that you're going to take the data, you're going to train the AI model up, you're going to test the AI model up, and you're going to implement the AI into a setting. Okay, we'll go on. So that's kind of gives you a start of it. So let's first look at something that you might already be familiar with. Because I think everybody here has had at least some level of familiarity with linear regression. If you've done linear regression, you know that you propose a model, which is normally an equation, and you throw numerical data at it, and you try to fit that numerical data to an equation that gives you decent predictions of what it is, of something. And every single one of those linear regression models, and you have people that have expertise in this, that can do this very, very well. There's the simple ones, like a simple linear regression, y equals ax plus b, okay, simple stuff, or nonlinear or multivariate. Well, linear regression can be done with machine learning. It's just a very, very simple model. In the machine learning AI, linear regression is definitely a possibility. And what will happen is you'll see that if you were to take a simple linear regression that you would do with your simple linear regression models and do the same thing with an AI, you're going to get pretty much the same results. Okay, we'll go forward a little bit. But there's some advantages here. One is a lot of data that you want to start with is highly dimensional. Okay, in other words, y equals mx plus b, that is one-dimensional data. It just goes to, there's two variables, y and x. However, if you have hundreds of variables, it's really difficult to use a regression model to try to fit that. And note, there's a limitation. It's numerical data or data that can be expressed numerically. It's all numbers. Machine learning doesn't have that limitation. So it's really good at very, very complex problems. Also, one of the beauties of it is when you train a machine learning algorithm using AI, some of the data is going to have no effect on outcomes whatsoever. There's certain variables that you think, well, maybe these variables are important, but in reality, they aren't important to the outcome. It handles that well. Okay, it also handles nonlinearity, because when you're doing numerical models in regression, you're pretty much limited in most regression models to linear regression models, which basically means you can express it in linear algebraic terms. Machine learning and AI doesn't have that limitation. Okay, so we'll go forward. So here's a good one. Good old predictive maintenance. So if you were to use a simple regression model to do a predictive maintenance, and I'm just going to use a nice simple example, but there's a lot more complex. The model of an automobile changing the oil. We're all familiar with this one. In the predictive maintenance for an automobile changing the oil, we know that oil performance degrades over time and can be plotted that way. Now, there's other variables besides time or mileage that do have an effect on oil degradation, but those are the biggies. And so we all do use, it's like, okay, well, how often do you need to change your oil? Well, most people will say every 3,000 miles or every 3 to 4 months. Why? Because we've made a linear regression of how the oil performs with those variables, we've set a standard of performance. And at that standard of performance, we said, here's where we should change the oil. And that is predictive maintenance using a linear regression model. It's very, very simple though. Okay, it doesn't, suppose you're driving your car hard or the engine's got other issues. There's all sorts of other variables that might be involved. But the reality is we just know to change our oil on a specific time period because we've been told to do that. Okay, so let's go forward. Now, what can you do with machine learning and AI with this? Well, in the last example that we had of the changing the oil, suppose we actually monitored all sorts of different parameters of the engine. How hard is the engine being driven? And when we talk about that, when we say how hard is the engine being driven, what are the RPMs of the engine at specific points in time? What is the temperature that the car is being driven under? What types of conditions do you have that you're driving under? Are you towing? Are you just driving? Are you driving city miles? Are you driving highway miles? Are you driving both? Most people that are familiar with automobiles will know all of those parameters do have an effect on oil life, right? Do we use them? No. Simpler just to say, hey, every 3,000 miles, every four months, just make the oil change, you're good to go. But when we're in an industrial setting, now we've got lots of things that we can use as input for predictive maintenance. And let's think about what those things are. One is we have historical maintenance data. It may be from a specific piece of equipment, but it may be from the same type of piece of equipment or the same model of piece of equipment from things that have happened in the past. That is maintenance data. Those are records that are typically kept. Parts that you've ordered, repairs that have been done, when the machine has failed, and the different reasons that we have for those failures are all of examples of data. Then we also have the good old operational data. How hard are we running this piece of equipment? And then we also have the environmental pieces of data, which are things that you actually physically measure on that piece of equipment. What pressure is it operating on? What is the temperature in the plant? What is the vibration level? Okay, simple things like how much energy is being consumed by that piece of equipment, which is an indicator of when the actual piece of equipment is going to need maintenance. Now, if you can take all the factors that go into that piece of equipment and come up with a prediction of failure, you've gained yourself a tremendous amount of financial, huge financial savings here, because how do you do it without this? How do you do it without all that data being used in the model? You just say, hey, we've been running the piece of equipment for 1 year, and the maintenance log says at 1 year we should go ahead and do these maintenances, and you do it. Do you actually need that maintenance? You might not. Okay, maybe you need that maintenance sooner because the piece of equipment is being run hard. In an ML AI setting, you actually use all this data to come up with very accurate levels of prediction. Because again, what is the cost of a piece of equipment going down, okay, early, and you don't anticipate it? Well, you have a loss of a piece of equipment until you can get somebody to come in and maintain it. And sometimes when you have a loss of a piece of equipment due to a maintenance issue, the cost of the repair is tremendously more than what the cost of the maintenance would be if you didn't do it. And anybody who's forgotten to change their oil for too long and has had an issue with that will know that one quite well. You don't want to forget to replace the oil in your car. And I've run into many people who are like, I don't know what the last time I changed the oil in my car is. It's like, you need to know this. Okay, but now suppose it tells you. So you're good. So now we can move forward. So it's pretty straightforward how this works. First, Well, first thing is you pick the type of AI network that you're going to use based on the data that you have. If you looked at the data that I had there, I have a lot of different types of data. What I'm not going to do today is go over all these different kinds of models. There's lots of courses, and this is an actual specialization inside of computer science to learn how these models are, what they do, and what kind of data goes with what kind of model to give what kind of prediction. That's an entire program of study right there. But the reality is there's lots of different types of models that you can use. You feed that model into the AI, and it fits that data to give you predictions. In this case, this is what it's doing. So for predictive maintenance, this is a type of AI that you can do. Then you test it. You always hold some data to test it, and you say, hey, I've got a much better predictor of when you're going to need maintenance. Okay, and I'm going to have to go faster now because I forgot. So keep going. We'll move forward. So, okay, it can detect. These are just things that it can do. And it can also give you recommended actions based on the data. If you have existing, so you can say, hey, you need to replace this part. You need to do lubrication here. AI gives you all that capability. Can a human do this, by the way? Sure can. If a human knows the piece of equipment very, very well and has been working with it, guess what? That's the point. But having an AI that can do it, you're no longer relying on a single human that knows that piece of equipment all the time. All right, so let's go forward. So some examples here. This was one of my favorite examples. I have some good examples that I like here. Bosch is actually putting this in, and this is in CNC equipment. They've got AIs running on the CNC equipment, and right now they're trying to. I know that from the article that they're working on putting it into all of the CNC equipment that they use in the Bosch plants, and that's all for making sure that they can do detection of any issue that can occur. Here we go forward. And this one is kind of important because I just wanted this. What's going on with this, just this picture? This is a picture snapped by an automated camera, okay? One thing that AI can do in that role of figuring it out is it can use images, and it can say, at this point of corrosion, we need to make a replacement. But it can watch that and keep an eye on it. And also the corrosion level has other, I mean, most people who know equipment go, okay, there's pitting that's going on. You can see in this case, there's a little bit of pitting, but it also is part of an entire system. So the AI can look at the entire system. Okay, let's move forward. But you can put in images in there. So some other things that you can do. One of this that's being used right now a whole lot is supply chain optimization. And the biggie right there is demand forecasting and inventory optimization are two of the big ones there. All right, let's I'm gonna go. I have to move faster now. I can see as I'm watching the clock too, by the way. So just so you know. Demand forecasting, it's really, remember, what did we do for demand forecasting before? Well, the forecasting of demand was actually looking at linear regression models. But remember what we have over regression models, we've got the ability to take much more input and get much more rich output. What you're really trying to do with demand forecasting is optimize your inventory levels so that you don't run into situations where you don't have inventory for your supply chain. Okay, and that's being done. And there's a ton of companies that do this, that do demand forecasting. Most of the demand forecasting that you'll actually see that's going on in almost all industries, there's companies that specifically have demand forecasting AI that they build for all sorts of purposes. Okay, you can do it in-house, by the way. There's also examples of in-house. Okay, we'll move forward. Inventory management. Inventory management is typically built into your existing systems that you have for managing inventory. Most places have that. Now the tools that are out there that deal with inventory management, and these are the big ones, by the way, Oracle, Infor, LinWorks, and C3. SkuVault got sold to LinWorks, and LinWorks is now running it. But these are four of the biggest ones that do inventory management. They all now use AI in the back end. It's being integrated into it. By the way, it's also integrated into your Microsoft products. You just don't see it very much. Okay, we move forward. Also, the same thing that you have in that whole management of supply chain and everything else also is applicable in the risk management side too. So what you want to do is you want to automate. And when risk management, we're really looking at here is, what are we going to do? What are we going to manufacture? And how much are we going to manufacture of that thing that we're going to manufacture? There's a risk associated with too much, too little. And the risk management tools do something in that they actually generate reports. Okay, that's kind of neat. It's like that when we go to our, we've all looked at the ChatGPT right now, which is great. You can say, ChatGPT, generate me a report on blah, 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 and it will do it. This looks at your data of everything that's going on and generates those reports. Still, just like ChatGPT, you need to read it with a little bit of a smart eye to know if it's there. But half of your work is done, and that is actually generated the report. Okay, we'll move forward. And the biggie, this is the biggest one of them all, quality control. And the biggest piece of quality control is visual quality control. It's easy to pop a camera in front of some piece of equipment or something that you're producing and have it snap pictures as it goes by. You can take those pictures very fast and then scan for defects, and then either have a rejection or acceptance process or an alert process. This is one of the biggest ones because it's low-hanging fruit. It's easy to do. Visual models are easy to do. And what do you need to make it happen? Training data. If you've got pictures of good and bad, you have everything you need to do an AI visual quality control of everything. And I've seen, by the way, when I do plant tours, I've seen this all over the place. This is the biggie. And visual models are now very, very mature in AI. So we're not starting at zero. Okay. Okay. Now, just some, and these are ones that I've actually seen. So these are the ones that I've seen AIs doing it. I'm pretty sure weld defects can go probably less than 1 millimeter, but this is a simple example. I can't tell you where these are because, again, I don't remember which of the different places I've been that I've NDA'd or not, but weld defects. Okay, you have welding, and then you have a camera that just goes and it pops out the weld defects. Circuit board manufacturing is pretty much used universally across the board. When you do circuit board printing, and anybody knows how circuit board printing works, you know they're printed things. Easy to spot. Some of my favorites, like food, spotting foreign objects in food. Most of what those foreign objects would be are hair and insect parts. Okay. And then also when you're using systems that use liquids that have to be put in there, like if you're creating a food substance that has a specific amount of liquid A and liquid B, the AI can actually monitor that you're putting the correct amounts in. That's one I've seen too. Okay, let's move forward. This is just, I just put this one as, this is a tool that is a visual inspection tool that you can actually play with by giving it images. This is available for free. Well, it's not for free. But you can go in and this is what my students are going to do. They're going to throw pictures at it and train it to spot bad and good. We'll move on from that. But I put that in the slide so in case anybody wanted. And another one of them does the same thing. This is one of the Azure products, is IoT Edge. And Microsoft also has, for at least for students, a free version to do development of visual AIs. So if you ever wanted to play with it, those are there. These are just some of my favorites. One of the things that's happening right now is they've got cameras. This is one of the municipalities. This one is a picture. The picture is actually from Europe, but There's cameras on the stormwater entrances that monitor whether they're blocked, because what happens if the stormwater gets blocked, we know in Florida, if it gets blocked, you flood somebody's house. So it sets up an alert, and okay. And it was cheaper than other methods to do that. Okay, another one. I don't know if you've seen these. These are just cool. I just liked them because they were really amazing. I don't know so much the visual inspection tool that's associated with it, or just the fact that they're using a laser to kill weeds in the field. A picture is taken. If it's a weed, it gets lasered to death. If it's the plant that you actually want, and the AI is able to look at the difference between the two. So it's just a good example of a visual inspection. And I think I had one more. And that also, by the way, that last one has a robot guidance system, which is also an AI. Those are now this one, if you do go visit, and I can freely say this, if you go to an Amazon fulfillment center, you will get to see lots of robots guidance systems going. And if you went to the ET Forum 2 times ago, you actually got to see an AI guiding a robot moving an arm to avoid people that might happen to just step in the way of it. That's also an AI. All right. And my favorite robot guidance system, I think, is the next one. The Roomba, which has the poop guarantee. Anybody who bought one of the early Roombas and has a pet might be familiar with what happens if a Roomba hits the dog poop. You pretty much want to throw your Roomba away. They don't hit them anymore. They avoid them. If they've got, I have a Roomba and a Shark. They both have visual guidance systems. The Roomba's is better visual guidance system, and it knows what it's looking at and will dramatically avoid, by quite a margin, any pet issues that are there. It knows what it is. No, it's not just saying, hey, there's something there, I'm going to avoid it. It knows what it is. So you'll still bump into the walls. And since I'm getting low on time, I'm going to move fairly fast through there. But all of these things that we've covered as things that are going on, all are process improvements. So one of the other ones which has a whole lot to it is waste reduction. That's also got an entire AI field going with it right now. But we looked at quality. So we'll move forward. And these are some simple ones. One of the things I really like about the AIs that we're starting to use now is automated report generation. I think anybody has to generate regular reports on things. You work all the time on generating stuff. Now there are AIs that you can point at all the stuff that you generated that will generate report summaries. And then you just look at it, make a few modifications, and you're good to go. That's also an AI. I'm using those. Okay, we can go forward again, and we're moving good. Now, here's one of my, and this is where I wanted to finish it up. Where are we going? Well, right now we've got tremendous use of very specialized AIs to do specialized things. And in the manufacturing sector, it's things that you either want high levels of efficiency that are really difficult for humans to do, or you just, an AI can just do it much faster. Where are we going? Well, I looked hard for somebody who was actually taking generalized purposed AI robots and trying to deploy them in a manufacturing setting. Right now, the Sanctuary, there's three companies that are working on it. One of them that's actually doing deployment, which is Sanctuary. The AIs aren't actually doing manufacturing on the vehicles. It's in a vehicle plant because there are already robots doing that. The AIs are assisting the humans that are doing the monitoring of the robots in tasks that need to get done. So they're actually in direct interaction with the humans in these settings. And this is a pilot. And the pilot is more to see how the humans and the robots can work together. So I'm going to tell my robot to go get me a cup of coffee. And if it brings me back tea, I'm going to fire it. So, all right. So, fast as I went through it very quickly, I know. What's happening? It's growing. It's already very, very widespread, but you know, in the world of business and manufacturing, it's all about the return on investment. And we're reaching a stage where the costs have come down, the technology costs have come down to the point that the ROI is very high, especially for tasks that can be fulfilled well by artificial intelligence. And a lot of places, it's just coming in because the tools that you're already using are getting AI enabled. All right. And questions? And you can do the video. I love my little video. This is what I had to find a video that did this. This is one of Boston Dynamics. This is Atlas, which is one of the robots that's developed at Boston Dynamics, which is really the leader in this. And there are right now available for sale. They're fairly expensive. 3 full multi-purpose robots. Atlas is one of them. That can do quite a few things. That's it. Questions? I know we went through this amazingly fast. Sorry, I had to. I had a lot of slides. And you can type the questions into the chat, or you can raise your hand and Teresa will set you up and I will be happy to give you an answer.
Carmen, go ahead. Oh, okay.
I see Mehdi.
Mute myself. So as you know, as Maury can tell you, can you hear me fine?
I can hear you.
Yes.
Okay. We are in the process of establishing a cloud-based cluster IoT cluster, where we plan to log our sensor data from our lab there and then develop some machine learning and have another app that taps to that data and develop machine learning for specific equipment based on the data that was collected. I was wondering if you could comment on some popular machine learning models that have been used successfully that will help us.
So
like
here's what I would.
Has neural networks ever been really successfully implemented in manufacturing?
Oh yeah, well, when I was talking about those models that replaced linear regression models as the type of things, those are all neural network models. And just think of a neural network as this. A linear regression may have 17, 20 parameters, usually 1 parameter per piece of data. You're not limited to that when you do AI models. In AI models, you do layers, nodes per layer, layers, and each node in each layer has numeric numbers that when it gets trained, each node, each connection is assigned a number, a weight. And you can then take that model, if you know layers and nodes, you can take that specific model with the inputs that come in and duplicate it. So that's all that's going on. It's just that that's a much more complex numerical model than a regression, so it can model better data. So you would still be using a neural network in your machine learning algorithm. The question that is always the one to understand is, what is the best model? Is a 5-layer, 25 node per layer model the right model for this data? You know, and that's where the people that are developing the expertise in this are saying, for this kind of data. And if I follow the research, I read the research notes every day. It takes me a little while. And there are right now models that have been out for a while. I mean, ChatGPT, the versions between 3 and 4 and 4.5 and 5's coming out soon. They're just optimizations of the existing model. Faster? Do you need it? Because what will happen is you'll go, oh, well, the weights on all these nodes are 0. You don't need those nodes.
Yeah.
So what happens if you remove them? Same performance, only with fewer nodes, which means one thing, it trains faster and it operates faster. Make sense?
Yeah, absolutely. I was also curious if anybody in the industry has actually implemented a
Oh,
neural net
yes.
they have? Okay.
Oh, yes. And actually, a lot of stuff that you saw is that implemented. And there's a mixture of people that hire companies to do it and people that develop this expertise in-house.
Thank you.
We have a question from Carmen.
Yes, hi. I enjoyed the presentation. I'm in the education industry and post-secondary. I was wondering, and I'm the program director for skilled trades, welding, machining, HVAC, and trying to kind of go over into manufacturing. Is there some kind of relationship between education and AI with machine learning? Or is it too premature and the engineers are only coming up with the theory right now? and
Well,
doing
the engineers are coming up with practical things that are happening. What we're trying to do work on now is where does this live in the educational spectrum? Because it's not just because if you're in CTE,
Mhm,
there's a certain thing that those people learn.
mhm.
But saying if you're working in, say, welding, which is a CTE, knowing how to weld is one thing, but I'm going to be willing to bet that pretty soon knowing how to have the AI, the visual inspection AI, inspect the welds and approve them might be something that they'll be learning soon.
Mm.
Are they going to be developing that AI? No. But will they be able to use an actual AI tool to do that? Probably yes. What will the tool look like? Well, that won't be what's happening in education, but that will be happening in the industry. And if the crowd, let's say the current practice in the future practice in industry is this in welding. You weld,
Mhm,
then you certify the weld by using an AI scanner.
mhm.
Okay. If that's the current, becomes the current practice in welding, what will you be teaching?
Quality welding, you'll be teaching, well, you gotta teach them, you gotta teach how to use the humanoid or to,
Yeah, I
to
mean, it may
scan
just
it?
be a little scanner camera that say, hey, this
Yeah.
is my scanner camera. I scan the weld now. I do the weld, I
Mhm,
scan the weld. I
mhm.
check to see if the weld meets the quality control.
So currently we're using bin tests, so that might be antiquated with this AI coming out that they might, I mean, or it could be a supplement or a quick way to identify it
I
sooner
use welding
rather
because
than
I
later.
know that there's AIs right now coming out that do weld inspecting that are starting to be used heavily in the industries.
So this is a form of quality control.
It is a form, in that case, it's a form of quality control.
control.
But what will happen is the industry of all the industries will be developing practices over time that are common practices that utilize AI for specific things. And as that happens in the industry, we as educators then have to turn around and say, we're not just teaching them how to make this, we're also teaching them the quality control, and this is how it's done.
Okay. Thank you.
You're welcome.
Are there any other questions for Ron?
I would just like to comment on one other thing. My background is engineering. I'm an electrical biomedical engineer. I worked at General Motors for 20 years, so I programmed the robots in the assembly plants. So to hear you say now they're coming out with this humanoid that's going to basically work with the operator, how is that gonna work? Maybe the humanoid can load the part into the tool, because see, I used to program those tools and program the robots. So, and those parts can be pretty heavy. So I'm just curious, how are they gonna interact?
That I'm actually quite curious of that too, because this is they're right now in a testing phase as a prototype to see what I think they're really even looking to say, what tasks do we actually need robots for? The robots aren't actually, in an assembly line, that those humanoid robots aren't doing the welds. You've already got robots that do that. The robots are actually there with the humans. And so they're participating in that too, somehow. I'm watching this
Yeah,
one pretty
how?
closely.
Yeah, because I'm curious. I know, the parts can be sometimes heavy, but you got, air handlers to help them load a part sometimes into the tool. And then
Yes.
they're going to remove that and then they're going to actually use the humanoid to assist the operator. But, you know, I'm just curious how those two are going to interact. I'm sure something has to be there to make the job go faster, better quality control loaded properly into it. I'm assuming something of that nature.
Yeah, and I will have, I'll be doing an update. It was all up to whenever they contact me and say, hey, we'd like to have another one on these questions. And I keep track of all the current industry practice and our education side of it. So we'll see what that, and I'm as curious as where, because things go in ways that you don't predict. I mean, some of the stuff is easy because it's low hanging fruit. Visual inspection, easy stuff. Mature AIs, image libraries, put them together, and it's easy to do. Now that we're starting to introduce humanoid robots into workplace settings, not your Amazon robots. So Amazon robots are not humanoid robots. They're little scuttle buses that go shooting all around, taking with a little, you know, they take a package off of here, run it over there. That's pretty straightforward stuff. Once you throw in general purpose robotics, you open up an entirely different world, but we don't know what that world has. Because I'm like, do you really need robots to do things that humans are good at and enjoy doing?
You have the human factor error that they always talk about. I don't know if they're eliminating that 10% human factor error or not.
Yeah.
But like you said, the humanoid is only as good as the input. So, so anyway, that's still being, you know, programmed by a human. So
Right, it
you
is.
got the 10% human error there. It's just in a different place. So I don't know. But it's curious. I am curious how that's going to evolve.
Yep. Same here. All right. I only went 20 minutes over. Sorry, Danielle.
No, you didn't.
No.
No, I still have time. I kept thinking we started at 1. We're good. Good. Then I can answer more questions. I started going really, really fast because I thought we were running out of time.
Are there any more questions at all for Ron?
Ron, I have just one comment to make.
Sure.
I believe AI actually helping human to develop more intelligently. And because I'm using that example that you used earlier in oil change in a car. And as a result of many factors that are affecting the oil to be changed or required to be changed, then we come to the conclusion, hey, why don't we create a sensor that constantly measures the viscosity of the oil? Another sensor constantly measures the filtration and debris that are inside the oil, and also the temperature, and then make decision that if the oil needs to be changed or not. Those sensors may not be in the market or may not be on that particular car, but we think about what we developed for AI to do. Now we can go one step further and make another sensors.
Well, my truck has one AI that is very, I don't know, it's intrusive sometimes. It has a sleep detection. If I'm sleepy or I'm driving a little bit erratically, it will pop up a message saying, we have detected that you need to pull over and take a rest.
Yeah.
And that's an AI. That's actually measuring and comparing it against known data of how people that are tired drive. So a lot of times I'm just doing it because I'm like talking and just somebody on the phone and stuff like that. But sometimes I'm tired. I'm like, well, yeah, you're right. I am tired. And it pops up on my screen. It pops up a cup of coffee. I'm like, yeah, that's a good idea. Coffee. I like that idea. So, that integration of, and you know, it's ubiquitous. And that's most of what the AI that you're going to use in the next 5 to 10 years, it's going to be ubiquitous. You're not even going to know. If you think about it, you know, that was an AI. But the reality is it will likely never even cross your mind that that was an AI.
That's true.
My wife car told her yesterday to hang up the phone. I'm not kidding. The display extended that she was talking on the phone and sent the display to her and hang up the phone. She got scared, called me. So why is it telling me that? He said maybe it's unsafe.
Yes, it's telling you that you're driving unsafe.
Yeah.
There is a question from Pauline. I don't know if Pauline would like to say it. Okay, she says a good presentation, love the potential opportunities, but how does a company implement? Do you need to hire experts?
Well, not really. So I looked at how companies were implementing, and there was always two choices there. One is develop in-house or subcontract out. And there's right now, because there's now quite a few companies that have expertise in integration of AI in different places and can give you a resume of these are the companies we've worked with to develop things. Larger companies will probably be developing some things in-house. And one of the biggest reasons for why the companies develop in-house was also the same reason why it was really hard to put together this presentation. They're very secretive about what they're doing because their use of AI in improving their processes or doing what they're doing for improvement is a competitive advantage. And they don't want other people knowing how they're doing it. But those are the companies that have the AI experts in-house, and they are also bigger. For the smaller companies, and I can tell you from my visit to the different companies that are around in my area, a lot of smaller companies would subcontract to do this. So if you're developing a process flow for manufacturing something, and you're looking at it, if you have a company that has AI expertise, they may turn around and say, a visual inspection right there will save you this amount of money. So let's throw some cameras in right here and then feed that into for visual inspection. Now, of course, if you know how to do automated flow, you're going to also have to set up, if you're going to say, hey, it's going to be an accept or reject option, you have to be able to now divide the flow into your accept, and which goes in the regular process, and here's your reject, which also, by the way, you can't just dump them someplace. They've got to have someplace to go. I've seen that. They've actually got a little thing, as it goes by, if the AI says it's rejected, poof, poof, there it goes. And it gets pushed off into another flow, which takes it someplace else.
Well,
Pauline, did he answer that, or do you want to?
I don't know if that's
have a
what
follow-up question?
because I think the original question was, do they do that? I know in the case of that one, they actually had the company that they were working with on the automation equipment had the AI equipment as part of what they were doing also. So again, that was more ubiquitous because they were purchasing equipment for their automation of their process. The company had AI built into their equipment that they were purchasing.
Yeah, so I run a small business, and it really, I'm thinking we don't have the AI expertise on hand, so it will be something where we would need to hire or subcontract out to a firm. What do you even look for in terms of identifying somebody that has this expertise?
Well, locally, here's what I would do is look to see who, if you're involved with either the Small Business Institute or a manufacturing association, ask others around to see who they've had good experiences with, because right now I know that some of the companies that claim to have AI expertise, it's not that good. And some of the companies that have AI expertise, it's excellent. And the reason for that is it's just relatively new. I mean, if you go into some fields that are mature, you kind of know who's good at it and who's not. This is not at that stage yet. And a company that doesn't have a lot of experience in the AI that is presenting, hey, we've got AI capabilities, we can develop AIs. Well, my students can develop AIs. They aren't that great. They don't work that well, but they work. They work enough for them to get a grade. So so I always go with recommendation.
Yeah.
As far as looking at where in your company that might be a potential, vision systems for quality control are always low-hanging fruit. If you've got an automated process where you can say, hey, I've got a rejection that occurs at a specific place with visual inspection, that's a relatively easy one. Because all you need to train an AI is, here's my bads, here's my goods. And those are simple AIs to train. Other ones get more complex. If you mix visual with textual with numerical, your AI just got way more complex, and you need people with more expertise to deal with it.
That's great. Thank you. Yes, thanks very much.
Professor Foltz, do you want to unmute and ask your questions?
Sure. First of all, great webinar. Thank you all for making this live to everybody. So thank you. And I definitely agree with the professor speaking that there's not very much resource right now, and the only way we can combat this is by doing it all together. So to go with that, though, my question in the chat was book materials to support a lot of the there's different companies out there making hardware, Festo or ATP or different revenues, but how do we support that classroom instruction with the labs? And I did mention in there, to go along with his statement, the low-hanging fruit. A lot of the thermal camera stuff now too is low-hanging fruit with the automation and with vision systems. What a human can't see is thinking outside the box, but normal for AI. But thank you.
Yeah, a thermal or an infrared camera looking at something and then doing rejection based on a temperature profile. That's pretty easy for an AI to do and very difficult for a human to do.
And that leads into like predictive manufacture or maintenance, as you mentioned earlier. That's a next step phase for preventive maintenance. It's really awesome.
Yep.
Okay, there's no other questions. I just want to remind everybody that following a webinar, I always send all registrants a copy of the presentation as well as the recording. And if you would like to have a certificate of attendance for today's webinar, you can reply to that email from me. Thank you so much for attending today.
Thank you.
Thank you, everyone.